Hello, bonjour, and welcome to the Don't Waste Water podcast. I'm your host, Antoine Walter, and in today's episode, I am extremely happy to welcome Imre Takacs as my guest. Imre is CEO and founder at Dynamita, the company that markets Sumo, a wastewater process simulator with open model source code. In this episode, Imre will reveal how he went in 40 years over 4 generations of modeling packages and what that implies for the users. He'll give us the single trick that allows to check if a few tens of $1 million process is worth the spending. He'll tell us how to optimize the treatment process or explore future challenges. And he will take us beyond the buzzword of the digital twin. This and much more will be featured in today's episode right after the credits.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Imre. Welcome to the podcast. Thank you for joining me. To start, I'd like to get a small postcard. So if you can tell us in a couple of words where you are right now, I think that could be fascinating.
Antoine, thank you for taking me in this program. I am right now, and for the past 6 years or so, about 40 kilometers from Nice, so in southern France, but in the mountains. The place is called Cigales, a little village perché.
Nice. Actually, I was talking about the postcard, but when I was reading your path so far in your career and in your life, I was under the impression that maybe you are the postcard yourself. So can you maybe guide us through your step and tell us where you've been over the past 35 years, I think, of your career?
Yeah, it's close to 40 or maybe actually 40 right now. I was born in Hungary and I worked for a research company there first. So that's very good for hands-on background. You know, as a young engineer, they send you out to the field. And I think that's really important for all the young people to actually smell the wastewater, not only model it. And then after a couple of years, I went to Canada. So I'm a Canadian citizen as well for 20 years. And that's when GPSX happened, BioWin. I mean, I contributed to their development. Mm-hmm. And then I arrived maybe 10 or 12 years ago, I think 12 years ago, to France, first to Bordeaux, and then to Nyons, then to this little place, Cigales. And we started to develop this Sumo software, super model, it's called. And ever since, we've been growing and we're having fun.
So you started your own company, right? Called Dynamita?
That's correct. Mm-hmm.
So can you tell us what's setting Dynamita apart in this wastewater world? What's your secret sauce?
Well, I don't think there are many people in this industry. Overall, it's a small market, obviously, just process modeling. But then maybe 100 or 200 people that are doing it. But I don't think there's anybody else who went through the same steps. First, the real plant experience, and then I've done 2 other models, as you know, from my background, VMP back in Hungary, then GPSX, then BioWin. I mean, I'm not claiming to develop them, but contributing to them. Mm-hmm. And then finally, understanding, I think, how this really should be done. And that's when I started 10 years ago. Dynamita, finding good people, a young, enthusiastic group, and we're all over the world. And that's how we got here, where we are now.
So you've mentioned the people and that you're spread all around the world. And I think that's really intriguing when I was looking at your company. Can you maybe tell us where you are, where the various people are located and what they do?
Yeah, so, even before COVID, or this is becoming a huge tragedy for the world now. Even before that, we've been working teletravail, so from home, everybody. So 11 people right now working from Madagascar. We have 3 in France, Toulouse and Cigales, Nyons. Then in Austria, Innsbruck. And then in Budapest, I have a developer group, which is 5 people. So it's a little bit everywhere, 3 continents. Oh, I forgot Canada. I have one guy in Canada also.
It's really a worldwide company. It's impressive.
Yeah, small but very widespread.
So what are the projects that you're working on right now?
Well, we can maybe split it into 2 groups. One is internal development. So we're obviously developing Sumo, the simulation software that we're selling. This had a yearly release. So Sumo 19 is what we have out, and Sumo 20 is coming up. Mm-hmm. And we're developing an industrial version of it, which is called Dynamita. And then this digital twin that you were interested in. These are internal developments. And then outside, we do projects. So it's very important for these companies to keep in touch with the clients and with the profession. So we have projects in Virginia, in New Zealand, in Japan, and also in France, several projects in France. So we have to balance, not wanting to grow too much. We still want to have fun and keep it as a friendly little company. But of course, we have lots of interest.
That's an interesting way to say that the fun is the key aspect, because I guess in our industries, it's sometimes, often, if not always, about passion. So the fun is for sure a key ingredient, I would say. You've mentioned that the key topic of today, what I was proposing you, is to deep dive into the digital twin. So I think that's a smooth transition. And actually, my first question in this deep dive would be, what I would like to understand is, you've mentioned that you've been working on several evolution of the model, but when you started with your very first model, what was the problem that the wastewater industry was facing, and why did it request a model to solve it?
So, I cannot claim that I started this modeling industry, obviously, but we understood it very early that the models existing at those times, they were kind of empirical models. So you were calculating, MLS as based on POD load. And if your residence time in solid residence time changes, then the yield will be different and you have to change a parameter. So to develop these, we call it structured models that we're using today, they are stable. They use the same set of parameters for all kinds of situations. And that is probably the stability of these models is what is a really big step. And actually, it all started in South Africa.
Okay. And why there?
There was a very smart and famous professor, Professor Imre. And I think he started the development in the late 60s even. And by the time this became a dynamic, the first dynamic model, we call it ASM1, that was in 86. So I started in 80. Mm-hmm. It was already a lot of development in this field.
How was it accepted by the profession that all of a sudden some computer are modeling stuff and you might have to listen to your computer and not to your gut feeling?
In fact, for a long time we said that only those people should use these models that don't really need it. They have the answer themselves by experience. Mm-hmm. But of course, it spread a little bit wider. So at the very beginning, maybe mid-80s or late 80s, we would have estimated that there is 200 users, potential users in the whole world. I mean, if it's not 10,000 today, then I would be very surprised. Just based on what we do, I don't have the business numbers of other companies, but, thousands of users running it now. But this took like 20 years to develop to this level.
So who were those 200? What was the profile of the people that really grabbed it from the beginning?
Oh, that was an estimate. First clients, or I would call users, because VMP was never commercialized. The first users, they were universities that found it. Obviously, a university student and PhD student that finds it very interesting and it helps in his project. So maybe that's where, for example, the University of Wageningen, we had very good contact with the Dutch people at Vituki. I was working at that time in a Hungarian research institute called Vituki. And we had, many joint projects. So they picked up maybe the first copy of VMP.
So it started with early adopters, mostly in the universities and in the schools. And you said that now it grew to maybe tens of thousands. But what happened in between? Can you identify a wow effect, or was it really an organic growth and people just joining the movement?
I believe that just the ability of these products. So first GPSX, which was the very first one that was really commercialized. And then BioWin, the other one is, it depends just on a couple of people. Peter Dodd is a big name in this industry. I worked for him. And once he had a user-friendly, easy-to-use product, that must have helped a lot in spreading it first in the US. The US still has the most customers, I believe, but it's spreading worldwide now.
So the user-friendliness brought the people to the tool?
I believe, because you can write these models in MATLAB or Fortran or anything else, but it's really, you have to have a specific knowledge to code in those languages. But in these packages, in these more modern packages, you have a user interface, you have buttons, you can drag things around. So it's easier to use, much easier to use them.
And did we reach the point where everybody is using it, or is still something that dedicated people really focus on?
That's a good question. I very much hope that we haven't reached a complete saturation. My experience is that the market itself is growing, so there are more and more people. Environment is important. IT and high tech is important. So it's in the crossroads of these two. And there are areas which are not covered at all. So, for example, China is huge. And you only have, I don't know the number, but it's a start. You're just penetrating that market. You know how many plants are being built there and how many people are just getting to that level.
And would you have some hypothesis to understand why countries like China don't pick it up?
Well, they had a more difficult history, of course, in the past. And I'm not saying they pick it up. We have a very good Chinese representative. And I mean, probably the other companies as well, our competitors. And it's starting, but it simply started a little later, maybe a decade later. Same in Eastern Europe. It's a problem with some more turbulent history in the past.
Okay. I'd like to go through 3 use cases, or what I imagine being 3 use cases. And therefore, I would start from the short-term use case. I would imagine that, let's imagine you want to treat a wastewater and you don't know how to actually treat it. And you would be modeling just to define your process. So first, is it something which is really a use case, or is my assertion wrong? And then how is the model actually helping to choose the process?
No, this is actually the most widespread use of this software. Meaning, you're designing a new plant and you want to make sure before you put in $100 million, you can spend maybe 50,000 checking it out that it will work the way you planned. So this is what you call short term, or the plant already exists. And you can try out many options. So you can shut down a reactor or open a reactor or quickly build one in the software. And that doesn't cost much money. You're safe in not violating effluent standards. So that is a very, very important use.
Can you maybe guide us through the steps? Let's imagine I'm a wastewater treatment plant operator, or my treatment plant is to be built, and I have some wastewater. So what do you start with? You take some samples to know what you have to input in the model, or they would take those samples and put them in the model, and then what do? They drag and drop some modules. How do I have to vision that? Well,
I believe that these are usually consulting companies with a lot of experience that design these plans or optimize them. So they already have an idea. They have a very good idea of what they want to do, but they may have 3 ideas or or they are not exactly sure what size of pump they need to choose. And then they can go to the model, to Sumo or another one, and try it out and influence if the plant is a so-called green field. So there is no plant, there's just wastewater. And then we need samples, and there is a sampling protocol. And once that is done, then that can be inserted into the model to get, the result that you can trust.
So I guess that brings us somehow to the second use case, which I would see, which is one you already somehow mentioned, which is this optimization aspect. So where you have a plant which is up and running, and you want to make sure that it's running in the best way. And somehow that's the digital twin now. So is it really like that you have the plant running, you do the digital twin, you compute on the digital twin, and if there is a drift between the results of the digital twin and the actual results in the plants, then you know that you have something to optimize in the plant?
Yeah, so maybe first it's a good thing to spend a minute on what is this digital twin, because it's a new thing. So there is not a fixed definition. I looked in many places, Wikipedia, everywhere. And some people, they just believe that this is a model. They define it as a model of the plant, which we've been doing for, decades. And some others think that it's only a digital twin if it's connected to the plant, it runs in tandem. So at the same time, in real time, and it's getting data and it calculates something that the plant can use right away as it's being calculated. I think the reality is somewhere in between, actually. So I think a connection is quite important, because if the engineer has to type in the numbers, then that's not always the most efficient way of doing it. But still, most of the time, this digital twin, we only have 4 cases at the moment. And as I said, maybe we have thousands of users. So it's really a new concept for that, the way I define it. So being really connected to the plant. You can do the analysis. So this optimization that you're asking about, let's say we know that our effluent has too much nitrogen and the limit will be going down. And then what can I do? And I could try to play around with the plant, but it's much more efficient and faster to play around with the model in Sumo. But I don't know if that is called a digital twin or that's just called an offline use of the model. So there's a bit of confusion. I mean, not a clear definition at the moment. That's what I wanted to highlight.
You mentioned that you have 4 use cases of a connected digital twin, but how would they be connected?
Well, these are some of these are not us, but done by clients. The ones that we're working, some are in proposal phase. So there's a design. So we know that we need to get a data into, and we have the tools developed for that. We need to get the data, so the flow, for example, how much flow is coming, what is in that influent. We need to get it to the software. And this is now not a big deal. I've done something like this 20 some years ago, and the sensors were not quite there yet. But now it's getting a lot better. And then the Sumo calculates something, and whether the plant can use that directly, which we call closed loop, or it just goes as an advice to an operator that we think your DO should be 2.3 milligrams. And then the operator can say, that's too much. I think 1.8 is enough. So both ways it would be possible.
But that means that basically Sumo is implemented inside the computer SCADA or something like that. So it's local in the plant. It's not somewhere in the cloud.
Yes, it's sitting usually on a computer that is cut off from the rest of the world, so that you cannot, somebody cannot hack it really. And it's only dealing with that one specific job that is given. Taking data from the plant, processing it, and providing advices, or talking directly to the hardware like PLCs, programmable logical controllers.
Okay. So that's for the case of the digital twin, which might be the one for the future, but which is not yet, if I understand right, the standard today. But you mentioned that there's this offline mode, which is much more used. So how does it work if you are in this offline mode?
So you mean the complete offline, or meaning there is data coming into Sumo and then we just provide an advice to the operator?
I guess the advice route, how does it work? Does the operator input some data into Sumo, look what Sumo is giving as an advice and then implement it? Or are there some steps which are automated? Or what's the best way? What would be your advice? How would you go?
Well, this is a very good question, and it really depends on how reliable these models are. So for simpler tasks, I wouldn't hesitate to connect directly to the plant. But for a more complex task, so there is these processes, nitrogen removal, called nitrification, denitrification, and phosphorus removal. And they are interacting. So when you have better nitrogen removal, then maybe you have worse phosphorus removal, and there is an optimum. And to find this optimum, you really have to have a very reliable model. So it means calibration over time and maintaining that calibration, because plants change all the time. One of my friends said, JB said, that plants are in steady state only when they are empty. Otherwise, it's a very dynamic environment.
So the big added value of the modeling aspect is that it goes beyond the capability of the human brain to play with all these parameters. And I guess that the model can give you the best equilibrium between the various treatment objectives that you have.
One is about precision. So yes, an engineer would be able to estimate how many blowers he needs to buy and what kind of blowers. We can calculate that, we can put in the peak load, which we still have to maintain DO in the plant. And then we can calculate it quite accurately. So maybe the error bar and the risk reduces by using the model. Instead of 20% plus or minus, we can go down to 5% plus or minus. And that means savings for the plant. They don't have to buy a bigger blower, and obviously this is expensive stuff. So we're talking here millions of dollars or euros saved by spending 20,000 on an evaluation or something like that.
So those millions are saving are on the CapEx. Did you estimate as well what you could save on the OpEx just by running the model? And it helps you. If it sets you, for instance, that the dissolved oxygen should be at 2.0, and that you see that you're running your blowers on turbo mode at 3.0, then of course, if you can put them again on the normal level and that you blow less, of course, you save on energy. But do you have an idea of what could be saved on the plants on OpEx?
Yeah, I mean, that's probably even more, because it's all the way. If you bought your blower, which is too big, and it's all the way uses too much energy, then that will be probably more expensive than just the price of what you bought. So I would think that operating expenses are more important in the long term. So, the life cycle analysis, we need to look at the whole. Building the plant, running the plant, and the lifetime of the equipment is maybe 10 or 15 years. The plant is 50 years. So we need to look at all of those. And to run a 50-year simulation in Sumo, if it's not a very, very complex and detailed run, which is also possible, but otherwise, so it might take 2 hours to run 50 years.
Wow.
So you can run many 50 years.
See, you got that wow effect now, but on me. So basically, if I understand you right, that means that those two steps should be fully correlated. The modeling is important to make the design, and then also the optimization. But if you don't start with the design, you're missing optimization opportunities, because you might find some optimizations, but still, if the blowers are overdimensioned from day one, you cannot run them at their optimum point. So basically, on the design, you have to make sure that you do the modeling so that you can leverage then this model later on in this optimization step.
That is correct. Well, the situation is that a lot of plants have been built, 10, 20, 30 years ago, even longer. And they may need an extension or an upgrade. So it's not always greenfield design. I mean, there's more of them in the countries that are just developing. In the US, we still have a couple of new ones, but it's more optimizing existing ones or upgrading existing ones.
Actually, this upgrade can happen because there's a new pollutant or a new charge or a new something coming to the plant, or there's a new regulation, like there's a regulation in some European countries on micropollutant removal, for instance. And I'm wondering how Sumo can be, I mean, that would be maybe a third use case, how Sumo can help to find the right treatment if you have something new coming to the plant. And now you need a bit out of the blue. You don't really have those 2-3 typical scenario. You just have to find something which is going to work. And how can Sumo be a right fit here to assist the designers to find this right additional treatment?
Mm-hmm. A model only knows what somebody knew and put into the model. So for a new component, for example, micropollutants or nitrous oxides are very important, starting to become very important for the greenhouse gases. So for these ones, first, usually this starts with model development and experiments. So we usually universities, but sometimes consulting companies take it on themselves to do some measurements either in the lab or on the plant. And from that one, we can understand what's happening with this specific, let's say, micropollutant. And then we can build the mathematical structure that describes the process. So on its own, the model is not going to know from something that is new, that is totally new.
For me to understand, well, what's the scope of your company? You have those two aspects of the software development and from the process side. And to which extent can you be the consultant and help your customers to use your model and to get the best out of it based on process questions?
Well, I mean, most of the time Sumo is used obviously by customers. We also do a few projects, but we're a small company and we don't want to become a Jacobs or some big consulting company. What can I tell you about this?
No, the answer is clear. The answer is fully clear. I think my bet now would be that you've said that the biggest potential is on the OpEx side. So probably if there are people which are not yet using a model, that might be the one part they should focus on, which is how to modelize their plan today and start to get some optimization potential. Did I understand that right? Is that really
That's right. When a plant that has never used a model and they get one, somebody decides that usually you need a champion, gets interested, understands that this is something which will save some money. And it doesn't mean that you have to fire some people because the plant will just operate better, but you still need the operators to operate it. The model will never grease a pump, for example. Mm-hmm. And that plant that just got into this modeling business, but they will need to pick up some knowledge. Of course, they will need to understand how it works. They will get some data that they did not get before. Then they will understand that some of their instruments are not showing the right value. So that is one good advantage of a model. The model always knows what are the mass balances. So always does them properly. And if you look at data from a real plant, it's very frequently, 20% of solids disappear somewhere, and it doesn't really disappear. It's just not measured properly. Either the flow or the solids is difficult, sampling location is not right. So the model can point out even such a basic aspect for the plant becomes better just by measuring better.
That's interesting. I'd like to understand your business model as a company. You have something which I'm really intrigued, to be honest. You are a software company and you propose an open source software. So why did you make that choice for open source against proprietary? And what does it imply for you?
Yeah, it's kind of unusual. I also have to qualify that open process source. So Sumo itself still needs to be licensed. So without a license, people won't be able to run it, except in demo mode. But the actual equations need to be shown to the engineers. There is one good example for this. When a user designs a plant, he has to put his stamp on it that I take responsibility for this plant. I designed it to the best procedures. If he did it using Sumo, then he can see what's inside and why these results that he's getting are calculated. In other packages, this is not as easy or maybe not possible at all. So I thought, and anyway, I'm not a businessman. I am an engineer. And I think understanding things is really important. And it seemed to be very popular with the universities, consulting companies, and plants even, that we developed our own language. It's called own simulation language, because you have all these languages that you need a programmer to C Sharp or others. So what we developed is Sumo simulation language, which is for engineers. An engineer can easily code in Sumo slang because it only contains the engineering knowledge. You don't have to declare double variables and all that. We do that for them once they have the model, automatically, I mean.
So does that mean that people use Sumo as their engine and then build additional layers on top of it?
That happens frequently. We have several big companies that are developing their own models in Sumo, and I don't even follow. Of course, sometimes we can get a question why this doesn't work, and then we help them. But even companies, so not only universities, academics, in academia, it's very widespread that a PhD student is building something totally new, something we didn't even know about. But even established big consulting companies may have a team that is developing for their own, preferred processes that we may not have. We cannot put in a proprietary process. This needs to be independent. Sumo needs to stay independent so that anybody can use it. Once we put in one specific process, that would be biased. So we can't do that.
So you mean that, for instance, one of the big players that has a specific membrane bioreactor, to take an example, but that would not be the generic one, but something which is branded, maybe patented, is something that you don't put in your model because that way you stay agnostic.
That's right. We can put in a general nitrogen removal or a heat treatment process, sludge heat treatment, a generic one, thermal hydrolysis, but we cannot put in can be as such, which is one specific patented process.
So when I was looking at the list of capabilities of Sumo, I was first planning on ask you what it can do, but when I saw the list, I thought I would rather ask you what it cannot do, because it sounds to me like it can do pretty everything. But is it everything, or are there still areas where you cannot do the modeling today?
I mean, modeling started, if I was there at the first ASMR release, and they started with just where to put your diffusers, so oxygen transfer, and how much sludge you will generate. That was only the two questions that they wanted. Now we answer a lot more questions, even about granules and, heat treatment and digesters and all kinds of things. But I don't think that we answer everything. So the greenhouse gases, for example, that's a fairly new field. We have a model for it, but how reliable that is. So we are more confident in the established models than in the newly developed ones. And that's a normal process, I believe.
Because you have more data to calibrate it, I guess.
Right, more history, and yes.
So does that mean that the next steps for Sumo is to embrace those areas which are not yet touched, or is it more to say that it should be cloud operated, or does that make sense at all to be cloud operated for a model?
Yes, absolutely. One new process is, so energy is becoming more and more important in this world. And one new process is capturing more solids at the beginning of the plant to generate in a digester, to generate biogas that can be converted to electricity. So the traditional models are not able to describe this, but we put it in maybe last year or so. So anything that shows up, usually in the research field, eventually will make it into Sumo, depending on our, the importance, what clients want. Industrial treatment is important. So we have a version of Sumo that is dealing with industrial wastewater or even ultra pure water. So these are fairly new developments.
Talking about industrial water, in industry, there's this trend to reuse always more of the wastewater as processed water or as gray water, the many uses of reuse, which means you could have a trigger to say that instead of the output quality, the quantity plays a role as well. Because if it becomes your processed water, then you want to make sure that your wastewater treatment plant is also producing the right amount of reused water. Is that something that you can model as well and integrate into your triggers?
Yes, we actually I have two examples for them. There is an industrial water company that makes pure water, for example, for LCD panels and those things. I don't know if I can give you the actual numbers, but it's 0.01% that is lost within one cycle. It's really, I was totally flabbergasted, and I see this is already exists. So that was one, and the other one, the recharge. So in Virginia, the soil is sinking because of water use, wells. So they clean. There's a project called the SWIFT project that they are cleaning the water to much higher standards than drinking water even. We're in that project as a sub-consultant, and we even have experts sub-consulting to us about ozonation and other treatment. And then this water is put back into the reservoir, into the groundwater, and it might come out, 50,000 years later. But they try to stop the soil subsidence.
That's really intriguing. And what about the cloud aspect? Is it something that might be used in the future to have the modeling in the cloud, or does that make absolutely no sense?
So, no, it's actually the cloud, that's an interesting word because it's really just other people's computer. It's sitting somewhere and you don't know and you don't care and you don't have to dust them off and, change the battery or nothing. Sumo can run in the cloud. The advantage is that you can, instead of having, 32 computers in your room, you can rent. You only need it for maybe 10 minutes. You can put 32 computers with a lot of cores, CPUs, and do a job that would have taken for you on your laptop maybe 2-3 weeks. You can do it in 10 minutes. And of course, it costs a little money because you need to rent these computers, but time is usually worthwhile to pay for.
So that's already happening today. Yes, you have, for instance, consultants which are using the Sumo Cloud version, and in that case, for them, what matters is to have the results quite fast.
There is no Sumo Cloud version. It's the exact same program that can be run from this cloud computer. So it's another computer that can be much, much better, much faster than what you can afford or what you want to afford. And also many of them. So it's the same. You just connect to that computer as if it was sitting on your desk.
Absolutely clear. So if it's okay for you, I propose you to move to the rapid fire questions.
Sure.
It's time for the rapid fire questions.
So let's start with the first one. What is the most exciting project you've been working on and why?
So obviously after this, it should be clear that, this baby, Sumo baby, this is all my life, this is the most interesting, exciting project that I've been doing. And why? Because we have complete control over what we do. We're also at the, I don't know if I can say that, at the mercy of the customers. If we do the wrong thing, they will leave us. So it's exciting, It's a little bit of a danger, but if it works, it's very, very rewarding.
So it's a strong incentive to do it right.
Right.
That's interesting. What's your favorite part of your current job?
It's absolutely free, and not only for me, but for everybody in the company. So if I want to go off and it's too hot and I want to sit in the swimming pool for the afternoon, that's fine, and I can work there as well. And if I want to work Sunday morning because something interesting came in, then I work Sunday morning and I take Tuesday off and go for a bike ride. And everybody can do this in the company. It's important that the job gets done. But this freedom, this does not exist really in many other places. You go in the morning, you leave in the evening. And it's also may not be for everybody because it's kind of, I don't know if I said it yet, but I don't think they ask, what is my work? And I don't have one. I have a hobby that pays my life. So that to me is the most favorite part.
So now first I'm jealous and second I'm curious. How do you coordinate with your team if everybody is free to work whenever best suits them? Do you still have some fixed meeting points where you can rejoin and make sure that everybody is aligned?
Well, we have a weekly call that most people can make Monday at 3 p.m. Before these travel problems and virus problems, we used to still get together in France here, maybe 2, 3, 4 times a year. So everybody, including from Canada and Austria and from everywhere. And that is still important. And then, we have Skype, we have Zoom, so you can talk to anybody at any time. And if they are not available at that point, they just put it into the calendar. Everybody sees. Somebody has a problem with their lizards. They have to go to the doctor. That's fine. He will work in the evening.
Okay, so you have really a strong company culture around this flexibility.
Absolutely. People are driven. That's what you want in the company.
Sounds really cool. So what is the trend to watch out for in the water industry?
I think if I have to say just one word, then it's energy neutrality. We can treat water to very, very high standards now, but it costs a lot of chemicals and energy. That's where this is going. Trying to look at wastewater as not wastewater, but as a resource and generate. There are some plants in the world which generate electricity, so they are energy positive.
So is it a trend for the future, or is it something which you already see today?
Well, if we have, 200,000 plants in the world, I don't know, I just gave a number, and 3 of them is energy positive, so it's just starting.
But if they were all modeling their process, I guess more of them would be energy positive.
It's the technologies, so, technology, once it's installed at the plant, it's going to be there for 20 years or longer. So it's not a quick change. It's not something that we can change overnight.
Okay. So what is the thing you care the most when you design a new product or a new process or a new release of Sumo? And what is the thing you care the less?
Mm-hmm. So one thing is really, really important, that it's user-friendly, that it follows the way the clients think. And that's why I think it's important to keep in touch with clients and with the actual profession. We do care a lot about how to use this thing without reading manuals. Nobody likes to read manuals.
And what would be the thing you care the less? Yeah, I know this one is the difficult one for everybody.
No, because I don't care a lot about maybe strange to say, or business plans and marketing. Obviously, we do that. You have to let people know that you're around, but it's something that if you have a good product, it almost comes on its own. So I don't push very hard. We don't have yet a specific marketing department or marketing guy. We don't even have a business manager, which we should, in fact.
So does that mean that all of that flows through you, or is it spread across the team?
No, I mean, there's this support at Dynamita.com, and I man that. I read that, and then I distribute it to whoever. And of course, I keep it together, but based on everybody else's contribution.
Okay. So do you have sources to recommend to keep up with the water and wastewater market trends?
Yeah, so there are two professional organizations. You must be familiar with them, the IWA, International Water Association, and WEF in the States, Water Environment Federation. And they have webcasts and their homepages and the newsletters. And I think if you follow those two, then you would be up to date. And then, of course, there are companies and websites from everybody. But I would direct people towards these two big professional organizations.
Okay, so IWA and WEF, and I'm going to put the links to the episode notes. And that leads me to my last question for today. Would you have someone that you would recommend me that I should immediately invite to the podcast, because he's a resource that should be shared with everybody?
Yeah, so there are giants in this industry. For example, James Barnard, who invented and developed the whole of phosphorus removal, biological phosphorus removal, or David Jenkins. And they are both of them are over 80, but they are sharp as ever. And so that's one aspect. And then I have my friend and business partner, Bernhard Wett, who's much younger than I am, but achieved an incredible amount of energy savings and developed new processes. So these are already three names.
Okay, so I'm going to invite them and let's see if they would be interested to take on the microphone. So Imre, thanks a lot. That was really, really interesting for me. So I guess it's going to be interesting for our listeners as well. So thank you for all this incredible input you gave us on modeling. And I hope to talk to you soon as well.
Yeah, thank you, Antoine. This was really enjoyable for me as well.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.